Yeah, guys, just doing a quick sound check, and I think we'll be good to go soon. Sweet. There is a few of us here today, which is lovely. What do we want to work on? Because I'm trying to think of what I did last time. I think I was working on a particular differentiation paper. Did you guys want to continue with that? Or if you have any questions or there's any particular topics you want me to cover today, just let me know. Either, I'm not really fussed. Or if we're like super quiet today, then that's all good too. Can go watch a bit of TV. Optimization questions in level 3 calculus. I'm trying to think. Is that like, I can't remember off the top of my head what the question would look like. Have you got a question in mind, Zoe? 578. I'm having a look at some questions from 2013 paper optimization question. Something like this. Should we try that question? I'll change the numbers so that we can kind of work around it. Okay, cool. I'll copy that. Give me 1 second. And I'll just need to change the question up a little bit. All right. So actually, no. We'll do the same one, and then I'll try and modify it a little bit. Level 3. Okay, give me a second. I'm just copying the question and pasting it. Where did I paste? Differentiation 2. Just waiting for the sync. All right, here we go. Where is it? Hey, Jack. Hey, Marco. All 3 streams, is it? Ready to change question? Okay, yeah, cool. All right, so what are we looking at? You need formulas for the cylinder. So volume formula for cylinder is pi r squared h, and that's pretty much it. That's all the formulas you're going to need. All right, so how do you guys want me to do this? Do you guys want me to actually go through the question first and then give you a similar question so you can try and do it by yourself? Or would you like to have a go at it? Or even like, how do you actually even approach a question like this? What do we want to do today? Sana, I think I saw a rate of change excellence question here. It's quite an easy excellence question, but like we can do it. So what am I doing? Am I doing this with you guys, or do you guys want some time to work it out by yourself? Okay, super quiet today. All right, so what I'm going to do is I'm actually going to work it out, and then if you guys want to, you could actually let me know, and then okay, all right, fine. That sounds like a plan, Zoe. So let's kind of do that. All right. So when it comes to optimization questions, right? Like one of the things that you will see is that you'll actually have like two different letters. All right. So as you can see in the volume here, sometimes I even go about it like I write down all the formulas that I am going to need for this. So the first thing is obviously volume of a, where is this? Let's go here. So I'm going to go into my formula sheet, and here, where do we have? Yeah. So if you look at the cylinder part here, so I've got pi r squared as the volume. Now it says the curved surface area is 2 pi rh. So basically these are the two formulas that I'm going to need for this particular question. So I'm going to write that down. So curved surface area is 2 pi rh. So the next thing that I'm going to do is, hey Clover, the next thing I'm going to do is I'm going to actually draw a shape of the cylinder, really, just to give me a visual idea of what's actually happening here. Now the curved part of the surface area is this part here. So that's like, if you think of like a can, it's the label that goes around the can. Now what this says, it says it's a closed cylindrical tank, which means you've got the bottom of it and you've got to add the top of it as well. So we've got the curved part plus we've got this circle at the top, and then of course you've got this circle at the bottom. Now that all of that is equal to 20, so that's what that first statement is saying. So 20 equals 2 pi rh plus the area of the red circle is pi r squared, and then the area of the green circle, which is the bottom, that is also pi r squared. So really we've got 20 equals 2 pi rh plus 2 pi r squared. So you kind of have to set up these equations first before you even kind of start differentiating, all right? Like really what we need to know, what we need to do here is we need to differentiate volume, put it equal to 0, and actually solve whatever the variable that you're going to differentiate it by. Now the problem is when we look at this equation here, we can't differentiate it straight away. So with optimization questions, it is always like, I'm almost 100% sure that you will have to substitute something else to get rid of the letter, one of the letters. So if you look at it, this particular volume equation, you've got an R and you've got an H as well. Ideally, you want to get rid of one of them. It doesn't matter which one, but you want to get rid of one of them. And in some cases, it's easier to get rid of the R squared. Some cases, it's easier to get rid of H. Noah, this is an excellence question, but I would actually say this is one of the more easier excellence questions, because all you really have to do is bring in your formulas together, rearrange one of the variables, substitute it, differentiate, and equals to 0. It's kind of like it's a bread and butter question. This is something that always happens in optimization. You'll have equation with 2 letters, and then you'll get another equation where you can combine these 2 letters. Like that's what's happening with that 20. And then you have to replace one of the letters out. So I'm going to try and eliminate H. And the way I'm going to eliminate H is, first off, I'm going to get rid of the 2 here. So 20 is equal to 2 pi rh plus pi r squared. 20 divided by 2 is going to give me 10. Now I want to have h by itself. And because I want to have h by itself, like you know, you might actually kind of go, well, how do I kind of rearrange this? That's, you know, it's entirely up to you, but like I would just go, well, I've got 10 minus pi r squared equals pi r h, and then h is equal to 10 minus pi r squared divided by pi r. So I haven't started differentiating at all. All I'm doing is just kind of rearranging it. So you can't differentiate if it's two different variables. No, Zoe, you can't actually differentiate if there are two different variables. So notice how the volume has the radius and the height. So you want to always make sure that that all those letters on the right hand side are the same letter, and that's what we're trying to do here. So by rearranging h by itself, what we're going to do is we're going to go back to that volume equation, and we're going to actually replace it with replace the h with 10 minus pi r squared over pi r. I'm going to pause there. Let me know if you guys have any questions with what I've done so far, and I'll put some line numbers as well. So if you have any questions, you can ask. Now, we haven't even started with the achieved part of this question. Silence is golden. Marco, that's because you're doing, which level, year level are you, Marco? Yes, Noah, it is, because optimization is still the same for level 2 calculus. The only thing is, I'm looking at this, does it require any kind of excess stuff? No, I think you should be able to do this, Marco. Yeah, you should be able to do it because it's just rearranging with some of the rearranging with some of the letters. Kalulas, yes, you can do that. So I'm glad you kind of asked that, but I will actually show you why I've not actually cancelled this. No, not really, Mel. It won't be wrong with it, because you'd still end up with something like 10 over pi r minus r, I believe. So you'll still end up with something. Now, there's a particular reason why I haven't actually, I know the questions you guys are asking are very valid. You're asking, why haven't I simplified line 8? Now, the reason I haven't simplified line 8 is because when I go back to the volume equation, so notice how it is pi r squared multiplied by h, and the reason I didn't actually cancel the pi r is because I know that there's a pi r and the pi r squared that I'm multiplying by. So in other words, check this out. So volume is equal to pi r squared multiplied by 10 minus pi r squared divided by pi r. All right, now it doesn't matter which way you do it, as long as you get the constant, the same equation as I do in the next line, you're pretty much good to go. So here I could actually cancel out the 2 pi's, and I can cancel out the r with 1, and so my volume equation is going to be r times 10 minus pi r squared, which means my volume is equal to 10r minus pi r cubed. Now if you can get up to line 9, 10, 11, 12. So if you get up to line 12 by yourself, in whichever format that you do, as long as you can get to line 12, you are pretty much going to be safe for this type of question here. So I'll pause again and just double check with you guys, like if there's any questions with what I've done so far. So Kalulas, you could have done it your way, where you cancel the r and pi in the bottom. As long as you can get your working to look exactly like line 11 or 12, then you are good to go. And same with you, who else had the question? Yeah, same with you, Mel. As long as you get to line 11 or 12, you're pretty good, pretty much good to go. Okay, so we still haven't actually started differentiating this question. All we've done is we've just rewritten the volume formula in terms of R. That's all we've done. So I know some people might be thinking, wow, this should be an achieved already. Unfortunately, this types of questions, you're not really getting an achieved for this because you haven't actually done any kind of differentiation at all. All you've done is just rearranged a bunch of equations. Okay, so Noah is sitting there going, it's like, hang on a minute, like how's this going to work out? Hang on, I'm just having a look at Beth's line. In line 10, if we cancel the pi r on the denominator, do we not cancel it on the numerator of the fraction too? No, because I'm assuming, Beth, you're wondering about the 10 minus pi r squared. No, we don't, because that's actually in a bracket. So we're not gonna deal with that at all. So what we are instead, this is like fractions, kind of like, how am I gonna say this? It's kind of like this, guys. Like when you have something like 8 times 16 over 4, you can't just cancel. I mean, 16 is probably a bad choice to do, but like let me put something like this. Over we go, 12 plus 4, something like this. Now if that's the case, I can actually cancel this to 1 and this to 2, but I won't be able to do something like this, because that's fundamentally it's not correct to do something like this, because there's a brackets involved in it. So that's part of the reason why you wouldn't do that way. I don't know if I'm kind of explaining it right. Hopefully I did, bet, but like because of those brackets, you can't just cancel out those pi r squared inside the bracket. All right, so with this question, awesome. So with this question, now that we have the equation for the actual volume, we could go volume is equal to 10r minus pi r cubed. Now it's actually saying that you want to find the radius so that this has a max volume. It also says that you don't have to prove that your solution gives a maximum volume. So all you're really doing is differentiating this. So dv dr is equal to 10 minus 3 pi r squared. And then we're basically going to say that dv dr is equal to 0 for max. So 0 is equal to 10 minus 3 pi r squared. Rearranging this, we're going to get 3 pi r squared equals to 10. R squared is 10 divided by 3 pi. And then r is equal to square root of 10 divided by 3 pi. Which, did I do this wrong? No, 10 divided by 3 pi. So I should get r is equal to, let's have a look. Yeah, so I should get r is equal to 1.03. Oops, sorry, didn't realize the clock was there. Hey, Sungwoo. So, yeah, that's pretty much it for this question, guys, because they're just asking for the r that's going to have maximum volume. And as you guys can see, the actual differentiating it, putting it to equal to 0 and solving it is really, really easy. It's just coming up with the actual formula to be substituting it for that height. That's the important part here. All right, so what I'm going to do is I will, once again, have some line numbers. If there's any particular line you feel like, hang on, how did he do that? Just give me a yell out. Otherwise, I will try and do a different version of this question. There are questions, there are other types of questions, you know, like if you think about all those questions where they have like objects inside an object, like a cone or a what do you call it, like a cylinder inside of a sphere and stuff like that. They all pretty much work on the same kind of ideology. It's just finding that H, finding a formula for the H, and then just replacing it, and then you're good to go. 2015 question 1E. All right, let's have a look. Somebody else asked that rate of change question as well. Just pasting it, guys. Give me a second. Yeah, it's not too bad for an excellence question, and I think like this is the same for level 2 or level 3. Is with optimization questions, it's always like you're gonna be using two formulas. So going back to what Zoe was asking, you're gonna have two formulas. One of the formulas will be like a volume and the other one is like a surface area or something like that, and then you've got to try and put it together in a way where it's like you have to link up the equations together and then get rid of one of the variables. And that's pretty much it. Once you get that formula nice and easy with just one variable, then you are pretty much good to go with that question. All right, so Mel, you wanted this question here, and I think this was a rate of change question. You kind of picked a lovely crazy rate of change question, because it's like there is a lot happening in this question, but we'll kind of try and work through it slowly. Can I make a suggestion? Maybe we can do 2013 one first, because this one there's a lot happening here, and I just don't want you guys to kind of get put off by it, but rather it's like there's another question I'd recommend doing first, and then we can come back to this question. No, look, you can do this question. It's just like with rate of change questions, it's like I always go like this, right? With rate of change questions, it's like they usually give you this two types of rate of change questions they have. Like generally speaking, what they have is like I'm trying to think of it like this. Like there's a two-dimensional one and there's a three-dimensional one. And it's almost like with the two-dimensional one, it's like the shadow is increasing as you walk across, blah blah blah. How fast is the shadow increasing at that particular time, right? Like that's like two dimensionals. A three-dimensional one is like something like a surface area is increasing at this rate, and then the volume is also increasing at this another rate, and then at what kind of radius will it pop or something like that, right? So they always have these kinds of questions. Now the way I kind of deal with rate of change is I'd go, it's like write down what you have, write down what the question is asking you to find, and then try and fill in the gaps in the middle. So you know what, forget it, let's just try this question. All right, so what we've got here is from a cone, slant of the cone is 30 degrees. Conveyor belts delivers salt at 2 meter cube per second. Let's just have a go with this, and then we can kind of work through it slowly. All right. So the first thing that we have is 2 meter cubed. So the thing that I like to do is I like to look at the units, because the units actually give me a clue what I need to write. So if you look at this is meter cubed, this is per minute. So this is going to be my first kind of statement that I'm going to put down here, which is dV dt, which is equal to 2. All right, so I'm literally looking at the units, because the units is telling me the change of volume over change with respect to change in time. Now there's a couple of things that's happening here. You've got the height, and then you've got the slant height. All right, so one of the things that you could do is I'm going to put the slant height as S and the little h as just height there. Now the question is asking, find the rate at which the slant height is S, increasing when the radius of the cone is 10. So they're asking for the rate at which the slant height is increasing. So the question is actually asking for ds dt when r is equal to 10 meters. All right, this is all the information that I have. I'm going to pause here, just check in with you guys. Is there any kind of things that are challenging at the moment? Anything that's like, I don't know how we got that. So all I've done is I've done dv dt, and the question is asking for ds dt when r is equal to 10 meters. Give me some sort of indication, yep, all good, move on. Or if you're stuck with something, just give me a yell as well. In this question, I don't think we need to use special angles because that slant is actually changing. Because the slant is not, or is the slant actually always, yeah, the slant will be changing, right? Because it's forming a cone as it falls from a conveyor belt, so that either the cone is kind of expanding or the cone is becoming more taller. So depending on what it is, we don't really know. But we do know that it has a 30-degree slant, so that 30 degree is consistent. Yes, Zoe, that's always correct. When they're asking you for rate, they're actually meaning over time. So in this case, when they say find the rate at which the slant is increasing, they're actually asking ds dt. If they ask you find the rate at which the radius is increasing, then the question is asking what is dr dt. You don't necessarily need to, Anonymous, but what you can do is you can actually use those. I know where you're coming from with the special triangles, but we'll kind of go through it, all right? So you can kind of have a look at a couple of ideas. Okay, so we've got a few other things that are happening here. One is we've got the radius of the cone as well. So if you think about it, we've got one more variable here, which is this thing right here, which is going to be radius of the cone. Right, so what are some of the things that we actually know about this? The first thing to have a look at is you want to be able to write, we've got ds dt, we've got dv dt. So how do we actually write the formula right? So that's what I'm going to try and do here. So this is all I have right now. I have got ds dt is what I want, and I've got dv dt. So this part of the equation is where I kind of need to figure out some connections, right? So with these types of questions, like the denominator is matching up. If you have a look at it, I've got dt, that's all good. What's another information that I have? The other information that I have is volume of the cone. So if you think about volume of cone, that is, let's go back to the formula sheet and pick up. So here is volume of the cone. So I'm going to write that down because usually with these shapes, you always have to use one of those things. And so in this one, volume of the cone is 1/3 pi r squared h. So that's the next step here, kind of putting that down as pi r squared h. Now remember in the previous question we did this. We had a problem. We can't differentiate that equation right now because there is an h, and we need to write h in terms of r, so that we can actually differentiate it. Now, the reason why I want h in terms of r is because when I differentiate this, I'm going to get dv dr. And what I could do is I could actually bring dv dr to this main equation, and I can put it upside down like this. And again, you might be wondering, why is he putting it upside down? Because think about it like this, all right? It's almost like I can cancel the two dv's, and my dt's are fine, so that's fine. But the next thing is I need to get rid of the dr, but I need to have an s in there somewhere. So theoretically, I should be multiplying by ds dr, because what this would do is eventually cancel those two things out, and I've got the ds on top there. Now, I know I might have kind of gone a bit crazy here, but this stuff in the pink box is important because this is going to tell you what are all the things you need to kind of create so you can actually solve DSTT. So what I'm going to do is I'm going to pause again, and I'm going to kind of just open the floor for questions, because this is possibly the most trickiest part. But if you can get this idea behind in this pink box, every rate of change question will become easy for you guys, like every single one of them. So if you don't understand what I've done here, please don't be shy, just shoot those questions, and we'll actually I'll try and work through it. Eswani, for this question, like we're not even up to the achieved part yet, because most of these questions, when it comes to like achieved part or merit part, is that you have to have combined the questions, the equations somewhere, and we haven't even done that yet. So we're still at the kind of like the beginning of the achieved part. But if you don't understand what I've done in the pink box, please ask, because that's like a key thing that you need to understand before we can carry on with this question. And again, if you're good, just give me a go ahead, and then I can start going through the rest of it. So Mel, if it's a merit question, it usually ends up being just 2 of them. If it's an excellence question, you end up getting 3 of these things. So with using pi RL, you're gonna get, so this is Adrena, I'm looking at your one, because we have these, right? So this is what we have, ds dt equals dv dt. I have a dv dt here. Now if you were to use the pi RL, where L is the, I'm assuming L is the slant height, but what are we trying to find with pi RL? Pi RL, what would that actually work out? I'm trying to remember. It's like, you got to refresh my memory. Is the pi RL, is it for volume, or is it for area, or is it for, what are we trying to do there? No, but we're not dealing with curved surface area here at all. We're only dealing with the volume and the slant. So unfortunately, that one is probably won't actually work in this case. Oh, pi RL. Okay, yes, I see where you're at. Now that won't actually work, because that's actually looking at the surface area of the cone, and we want to be dealing with the volume of the cone. So Esvani, in the pink box, what we're trying to do is, see, normally the kind of questions would be like, you know, it'll be like requiring 2 variables. So if I look at like area of a circle, and radius is increasing at a particular rate, what's happening with the area, blah blah blah. So they can actually have dA dt equals dA dr times dr dt. So dr dt is the rate at which the radius is expanding. The dA dr, it's just a equals pi r squared differentiated, which is equal to 2 pi r. So this thing here ends up here. Whatever the radius is increasing, that rate, so let's say radius is increasing by 2 meters per second, then this one would be 2 meters per second. So that's how you figure out how fast is the area expanding. So that's what we're trying to do in the pink box. We're trying to figure out what are all the things we're going to need so that we can actually solve this question. Now, as I said to you guys, like if you can get this question, I promise you, the next question, the next excellence question that we do, you're going to be like, yeah, I get it. It's so much more better. Okay, so what do we have here? We actually have, I'm going to have to get a different one. I already have what dv dt is, so that's done. Now I need to figure out what dr dv is. Now, if I go and have a look here, remember the previous question we talked about it. We can't differentiate a function with r if there's an h involved in it. And in this case, we actually have got an h. We need to get rid of the h, replace it with r. And the only way we're going to do that is go back to this triangle where you've got h, 30 degrees, r, and s. Hopefully you guys can see where I got that triangle from. That's the triangle from the middle of the cone. So once I have that, I could use basic trigonometry here and come up with opposite adjacent. So I've got TOA. So I can say tan 30 equals opposite over adjacent, which is h divided by r. So in other words, I can say that h is equal to r tan 30 degrees. Now that I've actually done that, I can go back to the volume equation and I can put 1/3 pi r squared times r tan 30. Now you can actually kind of, put down tan 30, but I'm just going to leave it there as much as it is. And so I get my volume equation, which is 1/3 pi r cubed tan 30. So differentiating it, what is it going to be? dv dr. So dv dr is going to be pi r squared. The 2 3's cancel out, and I'm going to get pi r squared tan 30. So I've done dv dr, which is I'm running out of highlighters here, but no, I've got another one. So I've done dv dr, but remember we're going to actually write that as dr dv, so I need to flip it. So dr dv is 1 over pi r squared tan 30. Okay, once again, I am going to pause that and I'm going to ask you guys, is there any questions so far? So I've done 2 of those 3 things that I need to solve this question. How did I differentiate the volume equation? And Beth, I've got your question as well. Now, the volume equation, remember that the 3 comes in front there, and 3 times 1/3, it just cancels out. You drop the power for 3, so 3 minus 1 is 2. Tan 30 is just a constant, so we don't really do anything with it. It's just a number. Pi is just a number as well. So the only thing that I really need to kind of worry about is the r cubed, 1/3 r cubed, converting it to r squared. So Beth, you're wondering why I flipped it? Because in my original equation right here, I needed the v to be at the bottom so that I could actually cancel it out. So otherwise what would happen is my equation would look like this: dv dt times dv dr times ds dr. And as you can see, I can't really cancel the 2 dr's and I can't cancel the dv, because on my left hand side I want ds dt. So I want this and this to be remaining, and the only way, how do you flip to get h over r? Oh, that part I just multiplied tan 30 by r. So, Beth, did that make sense as to why I needed to change this to dr dv? Because if I change this to dr dv, then basically the drs cancel out, the dvs cancel out, leaving me with ds dt. Yep, sweet. Okay, so now that that part's done, what else do we need? We need our last bit, which is the ds dr. So we're going to go back to our triangle again, and this time we need s in terms of r. That's going to become adjacent hypotenuse. So we're going to get cos. So cos 30 equals r divided by s, adjacent over hypotenuse, and then s is equal to r divided by cos 30. And finally, we just need ds dr. So we're going to differentiate ds dr. Now remember, cos 30 is a number, so when I differentiate r, I'm just going to get 1. So this will become 1 over cos 30. And again, I'm going to pause there. Is that a merit question? Where do you get merit for this question? Merit is when we try and do this next part. Swami. No, Zoe, we don't actually use quotient rule because it's not cos x or cos r. If there was a r in the denominator, then it's a function, and therefore you need to do it. But if you think about it, I could have actually calculated cos 30. So if I just go into degrees, make sure this is in degrees, and if I had done cos 30, it's going to give me this ugly looking number, and I don't want to write that down, so I'm just going to leave that as cos 30. Swami, this is level 3. Alright, any other questions with DSDR? If you guys are happy with it, then we are literally about 2 seconds away from solving this. Well, not 2 seconds, 2 steps. Okay, so we now have to put everything together, because here's the thing. We've got ds dt equals dv dt times dr dv times ds dr. So dv dt, we know what that is. That's 2. dr dv, we worked it out. It was 1 over pi r squared tan 30. And ds dr, we worked out to be 1 over cos 30. And this question asked, what is the rate the slant height is increasing when the radius is equal to 10? So all we're doing is literally just substituting 10 in there. So 1 over pi 10 squared tan 30 times 1 over cos 30. And that's pretty much it. So we've got 2 in the numerator divided by pi times 10 squared times tan 30 times cos 30. And literally our answer should be ds dt is 0.0127. 3 if you want. And you don't really need to worry. I mean, you can put units. Slant is just meters, time is minutes, and we're done. That's it. Anonymous, because you're actually got 30 degrees, you'd want your calculator to be in degrees. Medium mode. That's stats, mate. Like, I don't hardly do stats. So, guys, I think this particular question is probably one, like, I mean, there's a lot happening in this question, but I think if you can understand this question, what you'll find is the next question will actually make sense. But like I said, I mean, like, it always with rate of change question is always kind of it's like, what's the information that's been given to you? What can you work out? What are you trying to look for? Try and work out that pink equation box to try and make the pink like in the equation in the pink box. That's like a must in rate of change questions. All right, and then you kind of can figure out, okay, these are the things I have. How do I differentiate so that I can actually get to this particular thing? In terms of the significant figures, 4, I think they went with in this answer schedule, but it's not something they it's not like physics where they penalize you quite badly. So yeah. Would you like to try another rate of change question from the 2013 paper? Because I kind of put that out there. Let me know. I might actually give you guys like a few minutes to try and do it by yourself. Okay. So what I will do is you're gonna need the formula sheet. But let me just give me 1 second. Sphere. I will actually copy down the formula for you guys so that you're not scrambling around for the formulas. All right, so here we go. Where did it go? Oh, well, 2005. I don't even have the papers from 2005. But this is from 2013. So you've pretty much, I've given you guys everything you need. What I'll do is I am gonna actually step away from this. I'll give you guys about a good 5 minutes to try this. So we'll actually go through the answer at 8:53:30. Some questions are still useful, Mel, even though it's from the back in the golden ages. Some questions are fairly useful. So I'll give you guys some good amount of time for you guys to try and do this. Yeah, so give it a go and I shall be back. So guys, I know some of you guys are still working through this. Look away from the screen. I might just give some couple of starting points here, just so people can get, if they are feeling a bit stuck, they're not waiting like till 8:53 to do this. What'd you get, Sungwo? Alright guys, so let's start going through this now. This is, hopefully you if you need a bit more time, just now's the time to put it up on the chat. I'm going to give you 10 seconds before I start powering through this. Nope, we're good to go. Crozer. All right. So, what we've got here is we've got dvdt, which is 300. That makes it really easy. We've been asked to figure out what dsa dt is when the balloon bursts. I guess the first question is, what is the radius of the balloon when it actually bursts? It says when it reaches 7,500 centimeters squared. That's when the surface area, when it reaches, it's going to blow up. So I'm going to actually work out that first. So I'm going to put down 7,500 equals 4 pi r squared. So then r squared is equal to 7,500 divided by 4 pi. And then r is equal to 7,500 divided by 4 pi and then square root of that. Now this is to give me an idea of what r is going to be. So I've got 7,500 divided by 4 times pi. I hope that I'm on the right track there. Something doesn't feel right here. Give me a second. I need to make sure I put that bracket in the right place. Where's my calculator go? Because I get a feeling this does this thing here. Let's put a 4 pi like that. There we go, that's better. So r is equal to 24.43 centimeters. All right, now I've still not started this question, right? Now, remember I told you guys this. We've been given dv dt. We need to figure out what dsa dt is. So I'm going to write that down here. So dsa dt equals dv dt because I already have dv dt. I know that I have volume and then I've also got surface area. So if I differentiate volume, I'm going to get dv dr, and if I differentiate surface area, I'm going to get dsa dr. So straight away I can get rid of the dv by flipping it upside down. So I'm going to get dr dv times dsa over dr. Now remember, this is the pink box that I was talking about. Coming up with this equation is the important part of this question, because once you come up with this equation, then everything kind of just really falls into play. So I've got volume of a sphere, which is so volume of sphere is 4/3 pi r cubed. So dv dr is equal to 4 pi r squared. I've got surface area, which is 4 pi r squared. So dsa dr is equal to 8 pi r. Now all I've got to do is I've just got to go and substitute. I remember I need dr dv, so I need to flip this upside down, which is going to give me 1 over 4 pi r squared. So dsa dt is equal to dv dt, which is 300, multiplied by dr dv, which is 1 over 4 pi r squared, multiplied by 8 pi r. And what I can do here is I can cancel out the 2 pi's, cancel out the r, which is going to make it 1r, and then cancel out the 4 and 8 to give me 2 in the numerator. So what that's going to give me is 600 divided by r. Now I know what r is. I've worked out r was 24.43. So I could actually go 600 divided by 24.43 divided by answer. And that's going to give me dsa dt as 24.56 centimeters squared per second. That is basically it. Questions? Yeah. Is it okay that I wrote A for area instead of surface area? Will that put my... No, that's not a dumb question at all, Mel. You could actually write any letter that you want as long as you know what you're talking about. You don't need to put it as SA. You could put it as A. That's fine. Because it's just a variable at the end of the day. I think, like, when was the, like, let me just have a look at the exam paper for differentiation from last year, because this was quite a straightforward differentiation rate of change questions. It's parametric, positive, inflation, it's another gradient one, rate of change. Was there no rate of change? Yeah, see, this was an optimization question, but they had a rate of change question here last year, which was actually a merit. All right, and if I go back down to 2022 exam papers, differentiation. Oh, look at this, another rate of change question, merit rate of change question. I don't remember seeing, did I remember seeing an excellence one in that year? This is optimization, which was a pain of a question, that one. That was 2021. So there were two merit questions in the last 2 years. If we go back to 2021, geez, where did I put this paper? Sorry, I know I'm just kind of going through here quickly just to see where that. This is optimization. That's still. Here's a rate of change question. Which one is this? Now this one is another merit question, rate of change merit question. Maybe they changed it. Yeah, they all seem to be merit questions so far. Last paper. Let's just have a look. Differentiation paper. Did I actually do this? Where is this? This is going right back in history. Here we go. This was an excellence question here. This one here. This was in 2019, this excellence question. So yeah, like, I mean, it does come mixed, right? But it's going to be either a merit question or an excellence question. And if it does come as an excellence question, like, I mean, you guys can have a look at this and you can pretty much kind of understand what I'm trying to do here. Like, again, they've given the volume is increasing, they've given surface area is increasing, and you just kind of work it out, and you know, it's pretty much the same thing as what we just did, exactly the same one by the looks of it, because you've got the V and the SA. So that's with spheres, right? We can always do that. Anonymous, it's always hard to kind of answer that question, because you know, the whole point of examinations is try to give you like at least one tricky question. They don't want to give you guys all the same kind of easy questions. They will have like one question that'll be like slightly different. So yeah, so I mean, it's hard for me to kind of mention that, really. Like, I wouldn't be able to answer it, because like majority of the, like, see, especially with calculus, there's only so many questions they could ask you guys. Eventually there comes a point when you kind of go, oh, I've kind of seen this question before. I mean, like, this question that we did was from 2013, and if you look at that question in 2019, that was literally 6 years later. The questions are almost very similar, if that makes sense. Josh, with differentiation, the hardest part of the paper is actually coming up with equation under one variable. Now, if you are good with doing that, I can almost guarantee that you're going to walk away with excellence, because they will have all those excellence questions are basically learning how to, because in differentiation, we all know what we're going to do. We are going to differentiate it at some point, put it equal to 0, find the maximum or minimum, right? But it's the actual coming up of the equation that's the important part. And if you can actually nail that part, then I would almost say that you can almost walk away with an excellence pretty easily, because it's just learning how to manipulate those equations. Now, Marco has been waiting. Because he knows, and he's like, I want to go to sleep. This guy is just talking away random stuff. Give me my t-shirt so I can actually go. All right, so for those of you guys, it's funny how the numbers have suddenly gone up. We had like 19 people, and then suddenly we shoot up to 25 people. That's hilarious. But right, so we are going to do this. Sorry, Marco, I did get it wrong yesterday, but give me 1 second, I'll set it up. Zoe, Mel, hopefully it actually made sense to you guys, what we tried to do today. But there's a whole lot of people that are coming at 9 o'clock. Oh, look at that. They're all popping up here, and they all want the t-shirt. Where did these people suddenly come from? It's just hilarious. That's good to know, Zoe. So hopefully you got that sorted out. Right. So this is what's happening now. We are going to be doing a little kind of like a secret giveaway, which is not so secret anymore, because there's a lot of folks that are sitting around here going, it's like, when is this guy going to do the t-shirt? When is this guy going to do the t-shirt? But if you are around, look, literally we are doing this at the moment. Let me just put it up. There we go. I am going to need some names so that we can actually start populating this. Oh, Tushan's back. There you go. Oh, that's good, Mel. That's really awesome to hear, Mel. And I think you're pretty much on the money there. All right, so I'm going to start typing in some names. If you don't see your name, please just let me know. Tushan is there. Beth, Shania is back. Zed. Whoa, slow down, guys. Slow down. I'm trying to keep up. Ishan. Rihanna. Fran. Shania is back again. No. King Game, I'm going to put that as that because it just makes it easier for me to spot. Adrena. Palmer. Maya. Josh. Mel. Did we get Mel in there? No, she's in at the moment. Ishan. I thought I already had your name, Ishan. Godzilla is back. Tech Gaming. Kerry. Laura, are you in or out? Tom is in. Laura is in. Right. We're gonna give like another... Ah, Carol, you've got to be in it, Carol. Come on, let's... Why not? I'm gonna put you down, Carol. I got you there, Anonymous. I got you there as Tom. Alright, last call, people, last call. Talk about creating more work for myself. Okay, let me just refresh the stream just to see that I haven't actually missed anybody here. Don't think I have. I've got everybody. Marco, I've got your name correct, right? It's there. Alright, here we go, people. We're going to do this nice and quick before any other folks come jump on. Our first round is going now. Oh, is it actually spinning? I can't see. Is it spinning? It should be spinning. There we go. Very nice. Ishan, that's yours, mate. What size are we doing? Yeah, Sam, I'll put you in the next one. What size were you looking at, Ishan? Got it. And if you can just email me your email me your what do you call it? Your address onto my postal address. I will send it away. Dhruv, can't believe you missed this again. Dhruv, and then Zoe, I thought you were actually in there, but obviously I missed it. Zoe's there. Nell, and then who was it? Sam, was it? Gotcha. Alright, this is for the last one for today. Yes, Sam, I got you in there, don't worry. Ishan, like usually I go buy it and then I kind of just let me know what size you need, buddy, and then I'll get it done, alright? It's just something that I do in the break time. Well, not break time, in the, what do you call it? In the weekend I've got about a few t-shirts to do. So alright, Marco, here's Dhruv for you. Alright, hopefully you get this clicking along. Have I got your names in there? Where is it? I can't see. Drew's there. Yep. Carol's there. Yep. All good. Who is this? Cool. Everybody in? I've got your names in. Moment of truth, Marco. Moment of truth. Here we go, guys. This is for the last one for tonight. This is a nice way to finish the day, isn't it? Oh, surely. Look at this. Could it be? Of course it is. Dhruv, alright, I'm not sending it to you, Dhruv. You can just come and pick it up. You lazy fella. What size have we got on, Dhruv? Is it... I know, how long have you been in this? Sorry, Carol, you were so close. Sweet ass. I'll get that sorted, Dhruv. I think you can pick it up next week, Monday, from school. From across the road, you lazy. Ah, no worries, Monty boy. You're welcome. Just giving away some t-shirts for those hardcore learners today who suddenly went up. There was a massive spike at about 9 o'clock because they all figured out that I'm actually doing this at the moment, which is quite hilarious. It's like at 9 o'clock there's this massive spike in viewers. But hey, look, thank you guys for your support as always. Appreciate it. Those, Ishan, if you can send me an email, I will actually send it. No worries, Zed. By the way, we're doing this pretty much every night at the end of the stream, just for this week, as a bit of a bonus for people that have been kind of showing up So yep, I'll see you guys on Thursday. Have a good couple of days, and yeah, and I'll sort out Ishan, if you can just send me your postal address, I will try and send it to you probably on next week. I'll try and send it out. No worries, Beth, you're welcome. Sorry, Rice, you just missed it. See, I told you there's all these viewers come through. All right, guys, take care. I will catch you guys tomorrow as level 2, but the level 3s, I'll see you. And as for those other guys that are coming in for the 9 p.m. t-shirt giveaway, I will see you tomorrow at 9 p.m. Catch you guys. Bye.